Question 11. Which of the following is true of a particle in stable equilibrium? Now, generally, there are three types of equilibrium: stable, unstable, and neutral. Now, in neutral equilibrium, the particle that is displaced neither returns to initial position or moves away from initial position. So, in the case of neutral equilibrium, the potential energy is constant. Now, for unstable equilibrium, it is displaced further away. That is, the particle now is displaced further away from its initial position when slightly displaced. So the potential energy for unstable equilibrium is maximum. But this question is asking about stable equilibrium. And in stable equilibrium, the particle is brought back to its initial position when it is slightly displaced. So in this case, the potential energy is minimum. So the answer here will be C. Potential energy is minimum. Question 12. Determine the equivalent capacitance of the capacitors shown in the circuit. So we're given a circuit here with three capacitors. We can see 3 microfarad, 1 microfarad, and 2 microfarad. Now, the first thing we do is that we can see that the 3 microfarad capacitor and the 1 microfarad capacitor, they are in parallel. And we know that for capacitors that are in parallel, you add the capacitances. So we simply add the capacitance 1 and 3, which will give us 4. Now when we do that, our diagram now changes from this 3 and 1 now becomes this 4 here. So the capacitor now looks like this. Capacitor arrangement now looks like this. And so now this is a series combination. And these two new capacitors now are in series. And we know that for series, what we do is that we actually use the reciprocal. So it's meant to be 1 over capacitance, equivalent, or the total capacitance will be equals to 1 over 4 plus 1 over 2. Then you get your answer and then you find the reciprocal of the answer, which will be your actual answer. But JAMB is a timed objective exam and you need to be able to use short and quick ways to get to your answers correctly. So one thing you need to know is that if you are dealing with only two capacitors that are in series, just two, there is a way to get to the answer quickly, and it's a system known as product over sum. So you find the product of the capacitors and you divide by the sum of the capacitors. So in this case, the capacitances of the capacitors are 4 and 2 respectively. So that will be 4 times 2, which gives us 8, and 4 plus 2, which gives us 6. So when you divide this, you get the answer of 1.33 microfarad, which is option D. Now question 13 says the power factor of a series RLC circuit at resonance is. Now you need to know that the formula for the power factor is denoted by cos theta. So the whole of cos theta is the power factor, right? And it is denoted by the resistance of the resistor divided by the impedance of the circuit. So you know that the impedance of the circuit, since this is an RLC circuit, it involves both the resistance of the resistor, the reactance of the inductor, and the capacitor respectively. But now the question mentions something interesting. It says that the series RLC circuit is at resonance. One thing you need to know is that a series RLC circuit that is in resonance is purely resistive, right? As the reactance of the inductor and capacitors are the same. So the impedance of the circuit is basically the resistor's resistance. So in this case, this formula here, which is cos theta arrow over z, now becomes this arrow over arrow, because like we mentioned earlier, the impedance is basically the resistance, since it is a purely resistive circuit. And that means that this will be arrow over arrow, which means that our power factor is 1. So our option is B. Question 14. In the given circuit, so we have this circuit given here, we're asked to find the ammeter reading, given that the voltages across the capacitor, the inductor, are 300 volts each. So the voltage across the inductor 300, the voltage across the capacitor 300, but we don't have the voltage across the resistor, so we denoted it here as V subscript R, meaning voltage of the resistor. So now, like we always do, we write out all our given parameters first. And so we're given three parameters this time. The voltage, that is the voltage of the whole circuit, which is 220 volts as denoted here. The voltage of the inductor, 300 volts. The voltage of the capacitor, 300 volts. Now, the formula for the total voltage of a series RLC circuit is given by this formula. So now we have the total voltage of the system or the circuit, which is 220. We have the voltage of the inductor and the voltage of the capacitor, which are 300 and 300 respectively. And 300 minus 300 becomes 0. So 0 squared becomes 0 here. And this is only V arrow squared. I will know that anything plus 0 is that thing. So this just remains V arrow squared. So that will mean square root of V arrow squared be equals to 220. But we know that if you are finding the square root of a squared number, then it is simply that number because the square and square root will cancel out each other. So that means that our VR, which is the voltage across the resistor, will be simply 220 volts. But remember that we were not asked for the voltage of the resistor, we asked for the current reading of the ammeter. And we know that this is a series circuit. And one thing we know about a series circuit is that in a series circuit, current is the same across any load that is introduced into the system. So whatever the current is here will be the same current across each of these devices. So now we have our voltage of the resistor and we are already given, we have our voltage of resistor and we know the resistance of the resistor here, which is 100. So 220 over 100 will be 2.2 amperes, meaning that our answer will be B. Question 15. One of these is not an example of a mechanical wave. Now, one thing you need to know is that a mechanical wave or mechanical waves are waves that require a medium for propagation, meaning that they need to either pass through solid, liquid, or gas mediums. So, armed with that knowledge, let's get some of these options away so we can get at our option. Now, the first option here says sound waves. Now, we know that sound travels through air or solid or liquids, but sound cannot travel in a vacuum. So that means that sound is a mechanical wave. So that rules out this option. Water waves, it is actually in the name water waves, meaning that these are waves that occur on water, oceans and other water bodies. So that rules this out because it's a mechanical wave. Seismic waves, things like earthquakes, so they require earth, solid medium. So that means that this is also a mechanical wave. But then this last one, light wave. Now we know that light is an electromagnetic particle. So that means that it does not require any medium. So that means our answer in this case will be C, light waves. Question 16. Which of the following is a scalar quantity? Now we know a scalar quantity is a quantity that has magnitude but has no direction. So armed with this knowledge, you know that the answer will be A, electric potential, because electric field, you know, is a vector quantity. It has both magnitude and direction. Angular momentum and linear momentum, they are both vector quantities. They have both magnitude and direction. So our answer is A, electric potential. Question 17. Given three capacitors, each of capacitance C, the resultant capacitance of 2C over 3 can be obtained by. Now, the first option says combining all in parallel. If you combine all in parallel, we know that for capacitors, if they are all in parallel, you simply add. So if we add C plus C plus C, that will be 3C. So that is not the resultant capacitance we desire. So that is wrong. Now, B, all in series. Now, if you do all of them in series, that means that to get our answer, it will be 1 over C plus 1 over C plus 1 over C. And when you do that, you are going to get, when you find the LCM, that becomes, C, then, C into C, and that will become 3 over C. And then when you find the reciprocal of that, that will be C over 3. That's not what we're looking for. We're trying to get 2C over 3. Now, the next option here says two of them in series and in parallel with the third. Now, if we put two of them in series using our method of product over sum, right? Now, if we put two of them in series, the product of C and C will be C squared. The sum will be C plus C, which is 2C. So if we do C squared over 2C, one of the C's will cancel out the other C, leaving us with what? C over 2. then we add another C to it because they said it is in parallel with the third, but we're not going to get 2C over 3. So that means our answer will be D, 2 in parallel and a third in series with the combination. And you can actually see a proof here. Now, if two are in parallel, if two are in parallel, then that means we add the capacitances. So C plus C will be 2C. And so that means that our C equivalent now, because that means 2C will be for the two parallel and the third one will be just C. So product over sum, 2C times C, 2C squared all over 2C plus C, 3C. 1C cancels out 1C, 2C over 3. So that means we are correct and the answer is D. Now question 18 says, if two plane mirrors are positioned side by side, the number of images formed is 8. At what angle are they positioned? So now there's a formula to get the number of images, which is 360 over the angle minus 1. But in this case, we're given the number of images, which is 8, right? 8. And we're trying to look for the angle, 360 over theta. So that will be 8 equals to 360 over theta minus 1. And we take minus 1 to the other side, becomes 8 plus 1. That becomes 360 over theta will be 9, right? And if you make theta the subject of the formula, bring 9 down here, that becomes 360 over 9. And that means that the mirrors at an angle of 40 degrees, which is option B. Question 19 says, if the half-life of a particle is 4.5 days, how long will it decay 3/4 of its original mass? Now, let's assume that the total mass of the particle is 1 gram, right? Now, half-life is the time taken, time required for a quantity of a substance to reduce to half of its initial value. So, right here, you can see that this is 1 gram. If this particle were, you know, we assume that it was 1 gram. So, after 4.5 days, it will be half grams. After another 4.5 days, it will be a quarter grams. After another 4.5 days, it will be 1/8 of a gram, and so on and so forth. After another 4.5 days, it will be 1/16 and whatever. But then the question asks us that after how many days will it be 3/4 left, right? So we can find out here that when you add the first 4.5 days, will leave you at half. You add another 1/4, that brings you to 3 over 4. So that's already 3/4 of the particle gone. So that means that it will take 4.5 plus 4.5, which is 9 days. So it will take 9 days for the particle to have gone through 3/4 of its quantity. And that means our answer is E, 9 days. Now question 20 says a transformer core is laminated to reduce what? Now, these are all losses that happen in a transformer, due to various reasons. Due to the fact that, the current, that it's a transformer deals with, electromagnetic induction, alternating current, and the restance. So stepping up, stepping down. So these are all losses that are, happen due to those things. But a transformer core is laminated, you know, it's not laminated to reduce hysteresis losses. It's not laminated to reduce copper loss, and it is not laminated to reduce stray and dielectric losses. The reason why a transformer core is laminated is simply to reduce the eddy current loss. So that means our answer will be C, eddy current loss. Question 1. What is the force on a segment of wire that is 0.5 meters long and has a current of 2 amperes when placed in a magnetic field of 2 teslas at an angle of 30 degrees to the field? Now, the first thing we're going to do is that we're going to get all our parameters, and we're given 4 of such parameters. We're given the magnetic field strength, which are represented by B, which is 2 teslas, the length of 0.5 meters, the angle, which is 30 degrees, and finally the current, which is 2 amperes. Now, the next thing is that we know that the formula for the force on a current carrying wire is the magnetic field strength multiplied by current multiplied by the length and the sine of the angle. And so when we substitute all these values into this, then the force becomes this. But we know that sine 30 is 0.5. So when we multiply all this, we get 1 Newton, meaning that our answer is A, 1 Newton. Now the second question asks, a mode of heat transfer that is electromagnetic in nature is A, conduction. Now, conduction is a method of heat transfer or a mode of heat transfer but it's not electromagnetic in nature. Why? Because it requires solids. And a mode of heat transfer or anything that is electromagnetic in nature is independent of mediums. It does not need a medium to transmit itself. Now, the second option, evaporation. Evaporation is not a mode of heat transfer, so that rules it out. The third option, convection. Convection is a mode of heat transfer, but it requires fluids, that is, either liquids or gas, to be able to transmit heat, transfer heat. So that rules it out. But then finally, the radiation is the mode of heat transfer that is electromagnetic in nature because it does not require any medium to transfer heat. So that means our answer is the radiation. Question 3. A condition for resonance to occur in RLC series circuits is. Now we know that resonance, generally speaking, occurs when the external frequency of an applied force is equal to the frequency of the system which is receiving the applied force. So in this case, when we go through all the options, our answer will be A, which is when the angular frequency of the applied voltage is equal to the natural angular frequency of the circuit, meaning that our answer will be A. Question 4. A solid weighs 10.5 newtons in air and 5.5 newtons when immersed in a liquid of density 900 kg per meters cube. The question says we should calculate the volume of the solid and we're given acceleration due to gravity to be 10 meters per second square. So once again, the first thing we do is that we get all the parameters and write them down clearly. Now, this is the sign for density, which is rho, the Greek letter rho, and is 900 kilograms per meter cube as we're told in the question. Acceleration due to gravity was given as 10 meters per second square. The weight of air, which we are representing with W subscript A, is 10.5 Newton, and the weight of the liquid, which are represented with W subscript L, is 5.5 newtons. Now, the first thing we do is that we calculate the upthrust, and the upthrust can be calculated by subtracting the weight of the liquid from the weight of air. So that becomes 10.5 minus 5.5, which is 5 newtons. Now, but we also know that the formula for upthrust is density multiplied by volume multiplied by acceleration due to gravity. That means, therefore, this formula, which is also upthrust, will be equals to the upthrust which we've calculated here to be 5. And so if we make the volume the subject of the formula, then that makes V to be equal to 5 all over density times acceleration due to gravity. And we know that our density was given as 900, acceleration due to gravity is given by 10. Now when you solve this, you now get this answer of 5.56 times 10 raised to power minus 4 meter cube. And that is option B. Question 5 says a uniform meter rule AB balanced on a knife edge 60 cm from end B when a load of 22 grams is kept 10 cm away from the end A. What is the width of the meter rule? Now here is a quick sketch that shows or interprets the word problem diagrammatically. And we can see here that this is the support, which is 60 centimeters from the end B, like we were told. And this is the other weight of 22 grams, which is 10 cm, from the point A. But then we know that the weight of any system is at the middle or is at the center of the system. So if this is a meter rule which is 100 centimeters long, then that means that the weight will be 50 centimeters from the end. And so, equipped with this knowledge, we can now use the law of moment, which says that anti-clockwise movement must be equal to clockwise movement about the same point, right? So we're taking our movement about this point of the support. So if the weight is 50 cm from here and this whole place is 60, that means from here to here will be 10 cm. And we know that this is 60, that means this is a meter rule. From here to the other end will be 40. And if we remove 10 from that 40, that means the distance from here to here will be 30. Hence this formula here. So that is now 22 grams times 30 will be equals to W, which is the weight, multiplied by 10. So if we make the weight the summation of the formula, that becomes 22 times 30 all over 10. And our weight is 66 grams, which is option C. Now, question 6 says that a particle in simple harmonic motion while passing through mean position will have. Now, the mean position is simply talking about the middle point, you know. And for a particle in simple harmonic motion, you know that for the middle point, it is at the lowest point of the system, meaning that that is going to be minimum potential energy. And that is also when the system is fastest or the particle is fastest. So it's going to have maximum kinetic energy. And that means our answer will be D, meaning that it has maximum kinetic energy and minimum potential energy. Question 7 says that a pin floats on water due to the phenomenon of. Now, we go through each of these options. Viscosity is basically friction in fluids. So that is ruled out because that is not the reason why a pin floats on water. Now, if you look at capillary action is a tendency for a fluid to be able to move up, a tube, something that happens in plants when they are taking up water, from the roots through the stems to the various parts, and that is not why a pen is able to float on water. Gravitation simply talks about a body's ability to draw things to itself. So that is not the answer. The answer is surface tension. And you need to know that surface tension is a property of a liquid that causes the surface of the liquid to behave like a stretched elastic membrane. So in this case, when a pin is dropped on a water surface, the surface tension creates a force that supports the weight of the pin, and the cohesive forces between the water molecules are stronger than the gravitational pull acting on the pin, which allows it to float. So in this case, our answer is B, surface tension. Question 8. We're given four scenarios here. The first scenario says it converts electrical energy into mechanical energy. The second says it generates electricity. The third says it is based on the principle of electromagnetic induction. And the fourth says it follows Fleming's right hand rule. And the question asks which of the following statements is or are true for an electric motor. Now, one thing we know about an electric motor basically is that an electric motor uses electricity to do mechanical work, right? So the electricity is already the starting energy point, and then it uses that electrical energy to do mechanical work. So that means that the first scenario we're given, I, is correct, or is true for an electric motor. Now, if we look at the second scenario, it generates electricity. That cannot be true because, like we said, it doesn't generate electricity, it actually generates mechanical energy, because the starting point for an electric motor is electricity. Now, the third point says it is based on the principle of electromagnetic induction, which is also wrong because that only happens in generators where mechanical energy is converted to electrical energy through the principle of electromagnetic induction. So that's also false. And then finally, the fourth one says it follows Fleming's right hand rule. And for an electric motor, we know that it actually follows Fleming's left hand rule. So that means that our answer in this case will be option A, which is I only. Question 9 says that a thick glass tumbler cracks when hot water is poured into it because of, and we have four options here. The first one says the anomalous expansion of water. The second one says the thermal expansion of water. Sorry, the uneven expansion of the glass tumbler. The third one says the thermal expansion of water. And then the last one says the even expansion of the glass tumbler. And in this case, the answer is the uneven expansion of the glass tumbler, which is actually option B. And what happens is that the inner surface of the glass tumbler becomes hot and it expands more quickly than the outer surface. So, since the inner surface is expanding at a quicker rate than the outer surface, that's what causes the glass tumbler to crack. So, our option is B, uneven expansion of the glass tumbler. Then, question 10 says, which of the following is the function of a PN junction diode of a semiconductor device? Now, here is the picture of a PN junction diode, and as you can see, this is the anode and this is the cathode. One thing you need to know about a diode is that it allows electricity to flow in only one direction. right? As illustrated by this sign. You can see it allows electricity to flow in only one direction. So with this knowledge now, armed with this knowledge, let's go back and see the options we're given. The first option says it can be used to convert alternating currents to direct currents. The second option says it can be used to convert direct current to alternating current. The third option says it can be used to amplify the electric current in the circuit. And D says it can be used to step down the electric current in the circuit. Now, automatically, we know C and D are wrong because we just said that the job of a diode is to allow the flow of current in one direction. So it's not amplifying or stepping down anything. So these two options are ruled out. Now, between A and B, one thing we know about alternating current is that it changes directions. So when you look at the sine wave of an alternating current, you see it moves from positive to negative. But that is not what our diode is doing. Our diode is allowing current to move in only one direction. And which type of current do we know whose job is or which only allows current flow in one direction? Exactly, direct current. So that means that automatically B is ruled as because it's not converting direct current to alternating current. It's actually converting alternating current to direct current. So you can see this diagram once again. If you look at this diagram, you can see this part. So the alternating current is coming. When it gets to this part, it now gets changed into direct current, so it can flow in only one direction. So that means our answer is A. It can be used to convert alternating current to direct current.